Welcome to Miyconst Hardware. In my previous video I have demonstrated you what kind of performance you can expect from AMD Radeon Pro WX 7100 and 5100 in the stock configuration. In this video I'm going to tell you how you can overclock your WX 7100 and squeeze a little bit more of its performance. This overclocking method is applicable to any other Polaris-based WX graphics cards, such as WX 5100, 4100 and of course the 7100. About the 5100 and 4100 GPUs I will most likely make a dedicated video. In this one I'm going to focus on the WX 7100 and I will show you the results of stock overclocked WX 7100 compared to GTX 1060. But before I go into the overclocking subject, let me remind you that if you would want to buy any of these WX GPUs, you can do that on wstore.sk website. And if you apply my promotional code, you will get a 20% discount for your purchase. So now I'm going to walk you through step by step how you can overclock your AMD Radeon Pro WX 7100, 5100 and 4100 GPUs. In this case, I have a WX 7100, but for the other two, the procedure is exactly the same. Everything starts with the GPU-Z, so let's start the application. GPU-Z is needed for two things. First, we need to identify what memory is installed on your graphics card. For example, in my case, you can see that it is Hynix chips of GDDR5. It is very important to make sure that the BIOS you want to flash onto your GPU has support for this memory type. The best option is to save your original BIOS, mod it to your particular graphics card and use that one instead of picking up something from the internet. And for that we need to click this button which looks like Share, and here we click Save to File. When saving your graphics card BIOS, I strongly recommend you to name it according to your graphics card. For example, in this case I have named it a WX 7100, and since I have already saved the file, I don't need to save it again. After the BIOS has been saved, you can close GPU-Z and go to the next step. The next step would be to start Polaris BIOS Editor application. In this application, we need to click the Open BIOS button and navigate to the file you have saved from GPU-Z and open it. Here we will see all the important values about the BIOS, and in the top right drop-down you can see what memory types are supported by this BIOS. You can see that in my case it is supported two types of Micron memory chips and one type of Hynix memory chips. So if your graphics card uses one of these memory chips, you can use my BIOS options. If you have something else, you need to create your own BIOS modification. For overclocking, we can start with the easiest thing, the memory. The memory section is located over here, and I know that my graphics card is unfortunately not able to run at 2 GHz on memory, so maximum I can get is 1900. So I'm selecting this last row and then I'm going to the bottom section. Here we have two fields. So the first field is the row name and the second field is the row value. I need to update the row name. I write here 1900, and after that I need to click Apply Changes. After that you can see that the table has been updated, and now we see that the memory can go from 300 MHz to 1900 MHz. Important note here is that on the right side you can see a list of timings available for your memory inside this BIOS. In this case we have timings available for 2 GHz or 2000 MHz, which is good, but if these timings would not be available, the latest available timings would be 1750, and in that case overclocking might be limited to just 1800 MHz instead of 1900 MHz. The next thing which is easy to adjust in the BIOS is the TDP, or the power consumption of your graphics card. In case of WX 7100, we have one extra PCI Express connector, so we don't need to worry about power draw from the PCI Express slot, and that's why we can set TDP to 120 watts. Again, I'm selecting this TDP row, and this time updating the value to 120, apply changes, doing the same for the TDC row, 120, apply changes, and then the max power limit shall be set to something about like TDP plus 5 watt. So I will put it 125 watts, apply changes. The rest values you can leave as is. After increasing the TDP, I also recommend to update the fan speed. Over here in the fan section, you will find some fan options. And first we start with the fan speed. And we have 3 steps: minimal temperature, medium temperature, and high temperature. And right now we have 40, 65, and 85 degrees Celsius. I will slightly decrease the medium step temperature to 60 degrees Celsius. And the high temp I will decrease to 80 degrees Celsius. In this case, the fan will start to spin at the second speed with the 60 degrees Celsius and third speed with the high temp 80 degrees Celsius. We can also adjust the fan speed itself. For example, medium PWM in percentages from 40, put it to 60, apply changes, and high from 60 to 80. This will increase your GPU acoustics, or basically it will make your GPU louder, but it will help you to keep your GPU cool when it's overclocked. I also recommend setting target temperature to 80 degrees Celsius instead of 85 degrees Celsius. And what it will do, it will try to keep your graphics card below this temperature or at this temperature. And if it is not possible to keep this graphics card at this temperature, then the graphics card will start to drop its frequency to stay under that temperature you have specified. I believe that 80 degrees Celsius is a good value, but if you're fine with 84 or 85, you can keep it that way. We can also increase the maximum rotation speed of the fan. For example, from 3600 rotations, we can put 3800 rotations, and increase the acoustics limit. Here we can just write 1000 to don't really bother about this limitation. Now comes the fun part. Let's overclock the core itself. For core overclocking, we have this section called GPU, and here we have a curve between GPU frequency and voltage applied at this frequency. The last 2 rows are the most interesting for us, and I know that my GPU can work at 1330 MHz, but for this tutorial I'm just going to go for 1300 MHz. So selecting the last row, writing 1300, apply changes, and you can see the table has updated. So now our frequency curve ends at 1300 MHz, and the GPU will go all the way up to 1300 MHz. The difference between the last 2 rows is almost 100 MHz, so I'm also going to update the pre-last row to 1250 MHz, apply changes. Now, normally we would go to the values and try to underroll the graphics card, but unfortunately it doesn't matter what values I apply here, the GPU thinks that it's too smart and is able to figure out its voltage on its own. So I'm going to leave it as is, but I'm going to give you a guide what it means. So for these values you can specify it either in millivolts or in these encoded values. Everything starts with the base voltage in millivolts, and then we have these encoded values, which means voltage steps. For example, 65282 is 1 step above base. Then 83, 84, 85, 86, 87, 88, and 65288 is the last step of voltage increase from the base voltage. The GPU itself will decide how much to increase the voltage. These are just the steps saying that this is the last step. And if you would want to remove the last voltage increase and stay at the pre-last step, you, for example, here could write 65 to 87 instead of 65 to 88. And in my case, I know the GPU is able to work at 1 volt or 1000 millivolts with a 1300 MHz frequency, so I can just write the voltage over here like 1000 and then apply changes. But since this value is completely ignored with my GPU, I'm not going to write it in this tutorial. After the BIOS is ready, it's time to save it. For that, we click Save As, and when you're saving your BIOS, I strongly recommend you to give the file a meaningful name. For example, in this case, I write WX7100, the GPU name, then I write C1300, which means core 1300 MHz. Then I write R1900, which means RAM 1900 MHz, and TDP 120 means the GPU TDP increased to 120 watts. This is easy to understand, easy to remember, and you will not get lost with multiple of your BIOS options. So saving the file, and we are free to close the Polaris BIOS editor. The next step is to flash this BIOS to your graphics card, and for that we need a program called AMD VB Flash Win.exe. In this program, we need to click the button Load Image and select our pre-made BIOS. Important here is that right now in my system I have only one AMD graphics card installed, and that's why this top list has only one item. If you happen to have 2 or more AMD graphics cards installed into the same system, you need to select the correct graphics card you want to flush, otherwise you may end up in some sort of a brick situation. Once the correct graphics card is selected, click the Program button and wait until it completes. If a crash happens or the system locks and the process doesn't go through, then something went wrong and you have either applied too much frequency to your GPU or too little voltage. In my case, everything goes as expected and we get the confirmation that the BIOS was programmed successfully. Click here OK. Immediately after that, AMD flushing tool will propose you to restart your computer to take the effect of the new BIOS. Be careful here and do not let it restart your computer by clicking No. Close the flushing program. And now it's time to patch the drivers and sign the BIOS with ATI KM-DAG Patcher program. Launch this program. If you have already applied this patch once, you will see a notification that everything has already patched. In this case, you need to restore everything by clicking Yes to this dialog and wait for the restoration. Once it's successful, you need to start the patcher tool again. And this is what you would see if you would be running the patcher tool for the first time. So just click Yes to apply the patches again. Once the patches are successfully applied, you will see this little pop-up. Just click OK. If you forget or skip this ATI patcher application, then your graphics card will get an epilepsy hit after reboot, so be careful here. If the epilepsy happens, then you need to install another graphics card, boot with that graphics card and restore the BIOS of your graphics card while it is not connected as the primary GPU. Once you are done with the patcher tool, restart the computer. After restart, we are going back to our beloved GPU Z to validate that the new frequency has been applied. And for sure, as you can see, GPU clock is set to 1300 MHz and memory clock is set to 1900 MHz. Very good. Click on this question mark button to open the stress test window and then navigate to the Sensors tab in GPU Z, where we will monitor the status of your GPU. Then you need to launch the What Tool application. When you're trying to launch the application as a normal app, it will show you this error window. Just click OK and start the application as administrator. In this application, we can check this VRM monitoring checkbox so we can see in real time what are the VRM temperatures and what are the VRM voltages. After that, we can start the stress test in GPU Z. The stress test started and we see the GPU is indeed running at 1300 MHz and memory clock is 1900 MHz. But the voltage is rather high. It goes to 1062 mV, and I know for sure that my GPU can work at just 1000 mV. For that, we are going to use voltage offset setting in the What tool. For example, I can write -5 and then click Set. Immediately, the voltage drops a little bit, but that's not enough yet. Let's drop it further. -7, it goes lower. -8, it goes lower, and GPU still doesn't crash, so we can go all the way down to -10. I know that with my GPU I can lower the voltage even further, but for this tutorial it will do it. You will have to figure out what are the stable voltages for your GPU yourself, also run a couple of game benchmarks and see if your GPU is stable. If your GPU is overheating and not stable, then you need to decrease voltage and maybe decrease frequency. If your GPU is not overheating but also not stable, then you need to either increase voltage or decrease the frequency of your GPU or memory. And final thing to explain before I go into the test results is how to install your system if you have a graphics card with already modified BIOS. For that, we do the following. Install your Windows just as usual, and after that install official AMD drivers. Once the drivers are installed, they will fail to start and you will receive a bug report window. Just ignore this bug report window and close it. AMD installer will suggest you to restart your computer, and here you need to be careful. Refuse to restart your computer immediately and just close the installer. After that, you need to use the same AMD Pixel Patcher tool that I have mentioned before. Patch your drivers, assign the BIOS, and only after that restart your computer. If everything is done correctly, your computer should work just fine, and the drivers shall recognize the GPU. The only thing you would have to do is to set up the voltages again, because the voltage settings are preserved in the Watt tool but not in the video BIOS of your graphics card. Now let's talk about the performance. My Radeon Pro WX 7100 was overclocked to 1330 MHz on the core and 1900 MHz on the RAM. Starting with 3D Mark V Strike, in the stock configuration WX 7100 scores somewhere about 13,300 points. Overclocking the GPU gives us about 14,668 points. As you see, the increase is kinda substantial. For the comparison, we can take a look at the GTX 1060 score, and this graphics card scores 13,380 points. So just a tiny bit more than the stock WX 7100 and slower than overclocked WX 7100. In games, we have the following picture. Assassin's Creed Valhalla. Stock GPU gives us 4757 frames per second, overclocked 5061. Then moving to Far Cry 6, we get 6268 FPS, that converts into 6673 FPS with overclocking. Rainbow Six Extraction was 6182, became 6990. In F1 2021 we had 123 and 151 FPS, now we are getting 136, 167 FPS. Shadow of the Tomb Raider we had 5467 FPS and now we're getting 5771 FPS. Combining these all results together and getting the average, we see the following. Stock WX 7100 scores 6985 FPS, overclocked gives us 7692 FPS. So the difference is almost 10 FPS and I think it is substantial. For comparison, GTX 1060 scores in these games 7087 FPS. Means it is just a tiny bit faster than the stock WX 7100 and slower than overclocked WX 7100. So we have figured out that by overclocking WX 7100 we can push it beyond GTX 1060. And if GTX 1060 has only 6 gigs of VRAM, this one has 8 gigs of VRAM. And that's why I really like this GPU. It is small in size, it is not expensive, and it has 8 gigs of VRAM. At least it is not expensive on the wstore.sk website. Now, do I think it is worth overclocking it to get this extra bit of performance? After all, we need to do some extra operations to achieve the overclock, and we do lose the UEFI compatibility. In my opinion, it depends, as always. So, if you use this GPU in your personal computer, or maybe you are keeping it in your secondary computer and just want to tweak it to get the best performance, then yes, I think you shall definitely try to overclock it and get the best performance out of this GPU. If you do not want to overclock the GPU because you are afraid of the extra heat or you don't want it to be a bit more noisy, then you can still bump up the memory speed and reduce the voltage, so you will get slightly better performance with a slightly lower power consumption. But at the same time, if you're assembling a computer for your friends, for your relatives, or maybe for sale, then in this case I would suggest you to keep the stock BIOS, because the stability is much more important than some extra performance. You don't want to answer endless calls why the GPU is not doing that or doing that, and how to reinstall drivers, how to reinstall Windows, and so on. I am yet to decide what exactly I'm going to do with my WX 7100, and if you by any chance happen to know how we can get modified BIOS work with UEFI, or maybe you can figure out how to bake in voltage into the BIOS, then please let me know. While I have the GPU on my hands, I may try to test different BIOS options. For now though, that's all I can tell you, so thanks for watching, thanks for listening, and I hope to see you in the next videos. Bye bye!